I wanted to definitely go over how to create the form here inside of Rhino, then how to do the contours and development of the rest of the design inside of Grasshopper. Our first step is going to be to create the base geometry. And so what we'll do is we'll start here and we'll be creating this exhibit using a rectangle. So we'll start by creating a 3 foot by 1 foot rectangle. Then I'll take this rectangle and offset it to create a 1-inch frame on the outside. So I'll go to offset, 1 inch. Now that I've offset this to the inside, I'll extrude this up to give it some depth. So I'll type in extrude curve, and I'll extrude it by 2 inches. With this, now I want to use the cage edit option. So let's type in cage edit. Select the object first, and then type in cage edit. Then we want to select bounding box, C-plane, and then we'll use the defaults 4, 4, and 4. I'll do enter and enter. As you can see, we have 4 points on each plane, and we can use this to move this up and down. Now what I'm seeing is we don't have enough control points, so I'll actually undo it. And now let's try this again. Cage, edit, bounding box, C-plane, and then X, I want to type in 10. Y, I want to type in 5. And Z count, I want to type in 2. And now you'll see that for the Z, it'll be 2 points, 1 at the bottom, at the top, and then I'll hit enter and enter. So it'll be 10 this way, 5 this way, and 1 at the top and 1 at the bottom. Because now we can pick these and move them up. Now I can pick these and kind of move them in and pick a few points here that we can move in and out to create some kind of like a topography or a landscape. Bring this down towards the end. Same thing on the side. And so what cage edit does is it gives you a cage that is binds your entire object. Now you can use those control points to move the geometry and create this type of look. We can always change it using those points. So if we select the control point and type in or click on F10, you'll get the points back and you can move them and adjust it this way. So what I'll do is I'll take the sides, deselect the bottom. So I'll hold down control and deselect the bottom and then move these a little bit down. And same thing on the side. This is going to be what we'll be subdividing inside of Grasshopper using contours. And I'll use this back curve and I'll do extrude, curve, and extrude this down by 1 inch. So I'll delete the base curves because we don't need them. And this is what we'll use for the form. And so now what I'm doing here is I'm opening up a new script. So I'll go to File, New. Now we have a new script that we can start. First thing we need to do is bring in our geometry. So I'll double click here and go to a BREP or boundary representation. And this will let us pick this object, select this here, and go to set 1 BREP. Now I can take this and I can hide it because we brought it into Grasshopper and now we can preview it here. Then we can also hide the control point cage. And now we can start creating our contours. So what I'll do is with this BREP, this is what we want to subdivide. So next we'll bring in the component called contour. And there are different ways that you can do contour. It's going to be contour, create a set of BREP. a set of VREP or mesh contours. I'll use this VREP as our shape. Our point is where are the contours going to start from. So this is where I typically bring in an area component, plug the area component into the VREP, and that will give us the centroid, which we can use as our point of where our contours start. Then direction, it's going to be in the X, Y, or Z direction. For this one, I'll be going in the X direction. And the distance is going to be the interval in which the contours will be. So if we do 0.5, it will contour every half an inch. And so the larger the subdivision, you'll have less contours. And it starts where the point is. So with this, now we can extrude it by the same amount. So this is going to be contour, spacing. Now I can disable the preview on this and now create a boundary surface on those contours. Now with these contours, what we could do is take our surfaces and extrude them by half. So if we extrude them in the same direction, in the X direction by 0.8, so if we just type in do 0.8, we actually need a direction. So it'll be in the same direction as the contours. So this lets us create an even set of contours that goes from start to end. But if we do unit X and we do divided by 2, we now can create a space in between. So it's going to be 1 and then space, half a space that's going to be empty, then a contour, extrusion, then empty. And we can also do divided by 3. Okay, so with this, we've basically created the array, and let me show you how to change the direction. Now, this is one way. We can do the X direction. We can go in the Y direction, but that actually has to be paired with this one. If you want it to go the other way. So whichever way, whichever dimension you're doing that, you have to, in a way, flip it. But there is also another way that we can create a vector. So let me show you here. If we type in vector XYZ, we're actually able to create a vector using the X and Y. So if X is 0.5 and Y is 1, the vector, so let me see, this is going to be the vector that we'll use, and it can extrude it in that vector. So if we use this vector, so the direction, and then we also use this vector, so you see how it extrudes here. We use this vector using amplitude. So it's this vector, the amplitude is 0.8. Now we can plug this in here. Oh, it's actually this one. So this lets us rotate our array. So we do 1 and 1, it's actually going to be rotated. And this is another way that we can use vectors to create the direction. Now, we probably won't use this I'll just be doing it with the X array and in the X direction. Now the last thing, space. And the last thing that I'll be doing is creating a central spine that intersects with this entire contour. So it interlocks, and it, when you 3D print this or when you laser cut it, it will actually stack right on top of each other. So let me show you that next step. All right, so what I'll do is, first thing, I'll create a relay here because this is going to be the brep that we set. So I'll group this and call this set brep. Now this brep, we're going to create a box around it. So I'll double click, bring in a box component, which will create a box around our brep. Now this box, we can scale down to create that spine. So I'll go to an area component. This way I can bring in the center point of that box, and I can scale non-uniform using the box as the geometry, the centroid as the plane input, and the X, Y, and Z will be using the Z, and we'll be using the Y. So we'll do 0.5 and 0.5 to get started. We can always move these by disabling the preview on the originals. Now we can, actually no, the point was in the center, which is not what we want. We want the point right at the centroid, which is this. Yeah, this is how we have to do it. So this box has a bottom plane. So what I'll do is bring in a deconstruct brep. This way I can pick the bottom plane. So the bottom face by going to list item. And I'll go to index of 3. So 4 is going to be the bottom plane, and that is what we want to project onto. So we'll do project onto a plane. The geometry is going to be the point. So bring in the area component. Now we can use this center point from the box and project it down to this plane. And if I hide this, we'll see the point at the bottom, which is the point that we want to use for our scale. Otherwise, it won't work. Why? Because the centroid wouldn't be on the ground. And now we can use this and disable the preview on everything, including the box. And now we can scale this down we'll give it a few more decimal points. And same thing here. Okay. At this point, now we have this block that has to be a little bit lower than the entire thing. So I will also add a few decimal points here. 0.2. And now there are a few things, because we can technically just do a difference and subtract this from subtract all of the ribs or the array into this. So it's going to be a bunch of little blocks. Now I want them to be together, so this is what we have to do. Let's undo this. And rather than creating the Boolean difference right away, we actually have to bring this up by half of the distance. So if whatever this is, if this is 0.2, we want to bring it up halfway so it interlocks, and you'll see that. So now that we have this down here, we need to know how tall that is. So this is where I'll go to deconstruct brep once again, so I can pick this line segment to see what the length is. So I'll go to item. And since it's a box, I won't have an issue of the line changing. It's always going to be consistent. We'll go here to 3 and see if we have a line segment. 0, 1, 2, 3, and 4 is probably 4, 5, 6, 7, 8. Okay, so whatever length 8 is going to be half of that. So this is what we do. We pick that line segment. Then I'll go to a length component to know the length of it. And then I'll do divided by 2. And that is how much I'm moving this up by. So unit Z. And I'm moving up all of these. So move component, I'll be moving these up halfway. So I can subtract from this. So I'm keeping this, and I'm subtracting that entire script that I just created to move it up. Now we do have to flatten the input so it organizes it correctly and it intersects it halfway. Now I can disable the preview on this and the original. So you can see that if I take this, now this, and you can, now we're going to subtract the other half so that when you place that here, it's actually going to interlock, and it will make it a lot easier for it to be constructed because it will space it out for you. So with this, now we need to subtract it from the top. So I'll do a, well, first we need to take this and we need to move it down by halfway. So this will move again. I'll bring in a negative because we need to move this down. And we'll be moving down this form. Now with this being brought down, I can now do a difference. Solid difference between this is what we want to subtract, and what we want to keep is going to be this entire array. Now we do have to flatten the input. And you'll see here that now we have that subtracted from this. I'll disable the preview on this. And I'll take all of these and do middle click and bake. Now the page edit line's still there, so there it is. Now you'll see that this has that notch, and it even has it here on the first one, but you won't see it here. See on this side, and you do see it on this side. So you would almost need to subtract this end side a little bit. So this one could get scaled down by a tiny bit, maybe by 0.999. .98. Let's see if that works. Yeah. Okay. So now it won't intersect with that last one, and that's because it goes past the last one. So hopefully you're able to see that. We have this interlocking one, and then this one. And then we can disable the preview on this one. So this was an additional step. So you can have this mid rib that holds it all together. Let's take this and I'll move it in the Y direction, and you'll see here. I'll do 3.5 inches to one side, and then to the other side by typing in negative. And so we can have 3, and you can even exclude the middle one if you want to. Oh no, you can't, because it needs to be subtracted from that side and this side. So if these two are coming here, then we need to do the same thing with this. And these two need to be subtracted from the overall. So these here would be array, so I'm just bringing this out here to make it cleaner. This is going to be a geometry node. Okay, so these two are the ribs, including this one, or the spine, I guess it would be. In the array. And if I do divide it by 3, these will also be organized correctly. And if you do 1, it's going to be perfectly spaced, and the bottom rib probably wouldn't help as much. Okay, so let's go to 2. Now I'll take this and I'll bake it. I'll go to a new layer. I'll take these and bake them. Now I'll go back to our original, so I'll type in show and type in show. Select this, which I did with a different layer, and now I can move it over here so you can see how this ends up looking. Let's go to a clipping plane so you can see if I do a vertical section. And you can see here that they interlock perfectly. So if I were to take this and the ribs and create an exploded axon, so this would be the final result. Then let's copy this over and then deselect everything but the ribs or the array. I'll group it, then select the spine, group it. And now I can take this, isolate it, and you can see that if I move this up and I move this down, this is the exhibit of like an exploded axon. So you can see how it all comes together. And you can CNC or laser cut these pieces. The only one that's going to be tricky is going to be this one, because those pieces you actually want to go all the way through. Or maybe this last one can be cut off a little bit using the scale 1 dimension. But I wanted to definitely go over how to create the form here inside of Rhino, then how to do the contours and development of the rest of the design inside of Grasshopper. I'll be posting this video, the script and the model under my website, ComputitionalDesign.com. That's where I have all of the resources that you'll see here in the videos. Thank you very much for being here, and I hope to see you on the next one.